Hello, welcome and welcome back. 4 months ago, I failed. I had set out to make a War Machine Gauntlet that could actually shoot, and it sucked. It really sucked. So I made what I thought was the best decision at the time, which was to stop working on that first version of the Gauntlet and to make a completely new, better version of it. And I'm very glad to tell you all that that is what I did. To make a better version of the Gauntlet, we're going to be using completely new components. We're going to be using smaller breadboards, more powerful motors, new motor drivers, things like that. And we're going to be replacing the Raspberry Pi 3 with an ESP32 microcontroller. One thing that's probably the biggest change, last time we used cardboard for it, I'm not using cardboard again. This new Gauntlet will be completely 3D printed, and that actually reminds me of a funny comment I saw in the last video. Real the Dev 7336 said, "Someone give this man a 3D printer and he's gonna do wonders." And the thing about that is, I did have a 3D printer at that time. I have an Ender 3 3D printer. It's what I used to make my Spider-Man web shooter, actually. Right? People watch on their TVs are like, what is he pointing at? Sorry. Anyways, I've had this Ender 3 since like my sophomore year of high school. This is my baby right here, but to make a long story short, basically every print on this 3D printer could literally be its last. I almost couldn't even complete my Spider-Man web shooter because it was just having so many problems. It literally barely pulled through for that project. So yeah, if we want to 3D print this Gauntlet and this 3D printer is not going to work, then what do we do? Yep, that's right. We get a whole new 3D printer. Now, I am not at a point in life, okay, that I can just be dropping crazy money just for one project, okay? I've actually been meaning to get a new 3D printer for a while. One that's more new and reliable and doesn't require as much maintenance, And plus, this is an investment, I'm gonna be able to make a lot of cool things with this, so, it's a worthwhile purchase. But still, actually making the purchase and seeing that money leave my account, oh, man. But if you were to say, hit the like button or something, it would make me feel better. I'm not forcing you or anything, but you can. It's up to you. I don't know. All right, now that we've got all the yapping out of the way, let's begin. I started by testing everything on the Raspberry Pi 3. I wanted to make sure that everything was working properly and functioning like how I wanted it to, and then eventually transfer everything to the ESP32. All that previous test was just me getting more of an understanding of the new motor drivers that we were going to use in the Gauntlet. And I used the mini 3 to 6 volt DC motor for that test, but now that I had more of an understanding of the motor driver, it was time to whip out the new 12 volt motors that we were going to use in the Gauntlet. I wrote a new program on the Raspberry Pi 3 incorporating buttons into it now, and I got everything connected on the breadboard using wires. I also soldered wires to the new 12 volt motors that we were going to use. To power the motors, I ordered a battery pack off of Amazon that could hold 8 AA batteries. They're each 1.5 volts, so 1.5 times 8 is 12. Other battery packs I'd seen were a bit bigger, and like I said, we're trying to keep this as minimized as possible. And I was thinking about ordering rechargeable AA batteries, but I just never did. To basically explain how everything is working, we have a program running on our Raspberry Pi 3. We're using a GPIO extension board to take all of that voltage and put it onto our breadboard. It's sending over voltage and PWM signals, stuff like that. And we're using wires to lead all that voltage and PWM signals onto the motor driver. Essentially just the enablement and the forward function of the motor. So everything is being taken from the GPIO pins and inputted onto the motor drivers and then being output onto the motors. The 12 volt power supply goes directly to the motor driver using a screw terminal, and it is run through a regulator and then output to the motors. And that's basically how everything is doing what it's doing right now. Now that we've tested the motors and we know that we have a good setup put together, it's time to officially put the new 3D printer to use and print out a molder holder for the motors so that we can officially start launching balls and see how powerful they are. There was a bit of trial and error to find out a good distance to place the motors apart so that the balls would pass through easily. As you can see in this test, when a ball goes through, the whole fixture kind of jerks backwards a little bit. So I made some slight adjustments with the next model that I made, and this one was made to hold 4 motors. The previous test was still good though. I didn't angle my phone correctly, but when the balls went through the motors, they were like launching off my wall, so it was nice to see how powerful the motors were. And since just 2 of the motors were able to do that, it's time to fix the distance and see what 4 of them would be capable of. And I just push the button. We've got all our balls lined up. Now, as you can see, the balls are really like just going random places. You know, some of them go up, go down. It's just like sporadic and random. But when everything is closed off, we're going to basically make it to a point that the balls have nowhere to go but straight forward. I ended up printing out another motor holder that was smaller. At the time, I thought that when I made the AR for the Gauntlet that I would just slide the holder into place, but I didn't end up doing that. Now, to move everything over to the ESP32, I started off by having to order a breakout board for it off of Amazon because the ESP32 fits weirdly on a regular breadboard. This breakout board has screw terminals that connect to the pins of the ESP32, and it also has text along the sides of it so that you know which pins are which. Programming the ESP32 and getting everything connected wasn't that bad. The only difference between programming with an ESP32 and with the Raspberry Pi is that the Raspberry Pi comes with things like motors and buttons already defined, but with the ESP32 you have to do that by yourself. But we got it working. The next thing I did was I swapped out the bigger breadboard that we had been using up to this point with the smaller ones that I showed earlier. After that, it was time to add this to our electronics. This is called a buck converter. This specific one is a DC to DC buck converter. A buck converter allows us to receive a different output voltage than the amount of voltage we input into it. And the way you can change the voltage value is by rotating a screw on the buck converter either clockwise or counterclockwise. Counterclockwise decreases the voltage and clockwise increases it. This buck converter I have can only increase the output voltage that is input a little bit, but there are some out there that can increase the voltage a lot. Now, what is the importance of the buck converter in this project? I put together a little visual aid to make it really understandable. On the right, we have our 12-volt power source, aka our battery pack that holds the 8 AA batteries. We're going to lead a wire from that battery pack into a hole on our breadboard. When we do that, that makes that whole horizontal strip on that side of that breadboard 12 volts. We're going to insert wires into the holes of that strip and lead a 12-volt wire to one motor driver, lead a 12-volt wire to another motor driver, and we are going to lead a third 12-volt wire into our buck converter. Now, we're going to alter that buck converter to the point that it'll intake 12 volts and output 5. Now we have a 5-volt output from our buck converter, and we're going to lead that 5-volt output into the VIN of our ESP32. The VIN on our ESP32 stands for voltage in, and leading 5 volts into it will power on the ESP32. The battery pack needs all 8 batteries in it in order for it to be 12 volts, so nothing happens until we plug all the batteries in. So we can control everything running by just plugging and unplugging one singular battery. With the electronics aspect of the project complete, it was time to start designing the Gauntlet itself. I'm gonna kind of speed run this explanation just because I don't want this video to be like a million years long. The whole thing separates into 2 different parts. The part that I actually wear and that goes on my forearm is made up of 3 pieces. The top piece has a little square block on the bottom of it that sticks out. The left side of the Gauntlet has an area on the flat side of it that sticks out that has a hole in it. And on the flat side of the right half of the Gauntlet, there is an opening with a hole that goes straight through it. So now we can use the block that sticks out on the bottom of the top piece to keep the whole Gauntlet locked in place by sliding it through all those holes. War Machine has something that looks like this on his Gauntlet, so I added it for design, but also as a way to keep the Gauntlet locked together. On the bottom of the right half of the Gauntlet, there is a small opening, and on the bottom of the left half of the Gauntlet, there's a part that sticks out that slides into that opening. I just added that for more security. Additionally, on the right half of the gauntlet, there are 6 square holes in the back of it. Those correlate with the AR, where on the left side we have these 6 sections that stick out, and those slide and fit perfectly into the holes on the back of the right half of the gauntlet. This will make sure the AR of our gauntlet stays in place and stays attached to it. Now, War Machine's gauntlet, the way I'm assuming it stays in place is by these areas on the bottom that kind of hold the AR into place. But our AR needed to be a bit bigger than that one, so that just wasn't going to work. And I'll explain later why the AR is so huge. That's probably a question some of you are having. Now for the AR analysis, the AR is made up of multiple different pieces. Some cuts and edits were made just for the sake of 3D printing capabilities, because obviously we couldn't just 3D print the whole thing. On the bottom of the AR, on the left side / front of it, we have the area that our motors will be held at. And underneath that area is an opening so that we have room for the wires of our motors. Now on the right side / back of the AR, we have a section that our battery pack will be held in, and it has a slit in it so that the wires of the battery pack can pass through. In the middle of the AR to the right, we have 4 holes that will be used to screw and lock in our ESP32 and its breakout board. And to the left of that, we have 8 additional holes, and those will be used to screw and lock in our motor drivers. On top of the AR, enclosed inside is this piece that will act as an ammo holder. It has multiple angled walls inside, and those lead to an opening on the bottom of it. That piece sits directly on top of the barrel of our AR, which has an opening that is the exact same size, and the openings are for the balls to fall through. As you can see, the barrel goes throughout the whole AR, and on the front half of it, there are openings on the sides, and those are areas where our balls will make contact with the tires on the motors and be launched out. In the back of the AR on the top half, there is a specially designed piece that is meant to hold a brushless motor fan. I'll let past me explain the reasoning. Okay, here we have this. Very powerful, as you can see. So you get the concept, like it'll push the balls forward into the motors and then they'll be launched out. Okay, obviously there are more simple and easy methods to get the balls to be pushed forward into the motors. The only reason I thought about using wind power to push the balls into the motors was because when I was at work, I got this idea for this specially designed piece that would hold the balls, and no matter what angle it was at, like whether I was pointing the gauntlet upwards, downwards, straight forward, anything, the balls would drop down into the barrel and be launched out. If I was pointing the gauntlet upward, the balls would fall into the little rectangular stem that comes out of the side of it, and it would go straight down into the barrel, and at the bottom would be a brushless motor, and it would push the balls up and then push them into the motors and then launch them out. But this wasn't going to, it would have worked. I could have tried it, but we don't have space. That's the main thing about this project that's really getting to me, and really, just trust me, I really wanted to add this badly and make it work, as well as other mechanisms and things that I had thought of, but additions like those come at the cost of the gauntlet just getting bigger and bigger. And the design process of the gauntlet, like, I can't just make a change to one area or one side or nothing, you know? Like, if I were to make an addition, say make something longer or make something shorter, something like that, I'd need to, the whole gauntlet would need to be redone. It wasn't made like piece by piece or anything. The whole thing was just one solid piece, and then I had to cut it up and hollow out the inside and stuff like that. The AR itself is already pretty big. Most of its size is in its width, you know, like War Machine's, his gauntlet, they're not that wide, but mine had to be. Most of that size comes from the spacing of the motors. The whole thing was basically just built around the motor holder that we made earlier. I'm sorry if some of you are disappointed that I didn't go a certain route with this, or, you know, like add certain things or mechanisms, but I still think the end result came out pretty good. One final addition was on the top half of the AR. On one of the middle pieces, I added 2 square holes onto it, and those were to hold our on and off buttons. Before printing, I needed to change out the screw terminals on the ESP32 breakout board. With these original screw terminals, the wires would be inserted from the sides, and that would take up more space, and the wires would have to like bend awkwardly because of the design of the bottom half of the AR. So I ordered top entry screw terminals and swapped them out, so now the wires will be inserted from the top. To be able to screw and lock in the motor drivers and breakout boards, I needed to install heated thread inserts into the holes that I put on the AR. Now we can put screws into those heated thread inserts and lock our boards in place. The next thing I did was printed out a piece that the front half of the barrel was going to sit on. The front half of the barrel had to be split into 2 pieces. And as you can see, when the bottom half is leveled out on the piece that I printed, there is a gap between it and the tires so that the tires can move freely and not get caught up on anything. Next, I printed out the other half of the barrel as well as stands for it to be on top of. I had to do whatever I could to make sure that they were the correct height so that this half of the barrel would be leveled out with the other half. And so that there were no changes in height or gaps on the inside that would stop the balls from really going all the way through. Now to print out 2 pieces that are very important for this project, which were the upper back piece that would hold the brushless motor fan that I showed earlier, and then a funnel to somewhat pressurize and direct the air. The brushless motor fan sits perfectly in the piece on the back of the AR, and the funnel has a little opening on the side of it, which was for the wires of the brushless motor fan. Some air does get out of there, but a majority still goes through the opening in the funnel. The tip of the funnel fits perfectly in the opening on the back of the barrel, so we just slide it in and it just sits in there. Now air will be blown through the whole barrel. Next, to finish off the entire gauntlet, I started off by printing one of the middle pieces that would hold the on and off button. Then I printed out the other middle piece. Taking out the supports on some of these was a bit rough, but you know, we'll just call it battle damage. Then I printed out the ammo holder and I designed it so that I could add like a slider function onto it so that I could manually stop the balls from going into the barrel. Then finally, I printed out the left and right gauntlet pieces that I would wear on my forearm, as well as the top piece to lock them into place. Then I printed a cover/lid that goes over the ammo holder, and it has an opening on the side so that I can have access to the slider. And after adding these ramps to guide the balls, the gauntlet was officially complete. Well, that concludes this video. I've spent 4 months on this project, and could I honestly sitting here say that I am satisfied, you know, with the results? Oof. The whole goal was to make a better gauntlet, and we did that, you know? It's better than the last one. But is it perfect though? That's the thing. Is it perfect? I honestly can't say so, but enough War Machine, okay? I need to chill out I need to relax. I need to chill, okay? We're gonna move on to the next project. We're gonna move on to the next thing. In the future, I will probably definitely make a Mark III of the Gauntlet, okay? And I know how to make it perfect, like literally perfect, okay? But as for now, this is good enough, okay? Anyways, if you guys enjoyed the video, you know, please give it a like and also subscribe with notifications for future uploads. And also comment down below what you would like to see be built next, okay? Because I'm open to anything. And also, I have 4-month gaps in between all of my videos. You know, that's not intentional. That's not, you know, I'm not trying to do that, okay? But summertime is coming up. I'm changing my schedule up, things like that, okay? So the next video should not take 4 months, okay? That's not the type of creator I am, okay? I promise. And not the type of creator I'm trying to be either. Anyways, I will see you guys in the next one. Take care of yourselves. Take care of one another. Goodbye.